Okay, so now we're on to example 2, which says 2 stones are launched from the top of a tall building. One stone is thrown in a direction 30 degrees above the horizontal with a speed of 12.0 meters per second. The other is thrown in a direction 30 degrees below the horizontal with the same speed. How much longer does the stone thrown upward spend in the air compared to the stone thrown downward if the building is 120 meters tall? All right, so the first step is to gather our information. So we have that the initial velocity for each of the stones, let's go with this one. For both stones, the initial velocity is 12.0 meters per second. And again, this is the speed of the stones, but the stones each have an angle. So we have 2 stones. Stone 1 is going up at a 30-degree angle. And it's really this hypotenuse here, which is our V naught. Why this won't let me draw right there. This is supposed to be a 2. 12.0 meters per second. And really what we're interested in is this V naught Y. And 2, same thing, except for now it's thrown down at 30 meters per second. And again, this hypotenuse here is V naught, which is 12 meters per second. And we're again interested in this V naught Y. We also have that the height of the building is 120 meters, and we know that G due to gravity is 9.8 meters per second. Okay, so and the question is, we basically need to find the time for the first ball to fall, or stone. So the time for fall of first stone. And we want the time for the second stone to fall. I'm going to write in cursive so I don't tap so much. And what we're really interested in is T1 minus T2. That's what our final question is. Okay, so let's move on to organizing our approach. So organizing your approach is different from gathering your information because it just gives you a little bit more detail. It helps you. And what we're gonna do is we're gonna draw a picture. So let's say we have a building. The building is 120 meters tall, and we're going to say that there's 2 stones. There's stone 1 and there's stone 2, and they're each thrown off at different velocities. The speed is the same, the velocity is different because of the direction being different. And some things that we can organize our approach on now, again, is looking at that V naught Y for stone 1 is going to be equal to, we'll just draw a little picture here. So again, this is 12 meters per second in the upward direction. And so that means V naught Y is, we're going to have to use our trig rules here. So we've got that I like to use some old hippie. So that sine is equal to opposite over hypotenuse. Hypotenuse is the 12. The opposite is what we're looking for, which is our V naught Y, and the sine is sine of 30. So we know that V naught Y is equal to V naught times the sine of 30 degrees. This is for stone 1. For stone 2, we know that V naught Y for 2 is, we use the same exact equation. The only difference now is that this 30-degree angle is now negative 30 degrees, and we're again still interested in V naught Y. So we do the same thing. Sine is equal to opposite over hypotenuse. So V naught Y is V naught times the sine of negative 30 degrees. So we can actually plug in these numbers here. We can actually plug in these numbers here and tell us that V naught is 12. I'm doing all kinds of crazy things here with my little board. Times the sine of 30, which is 0.5, and that equals 6 meters per second. The sign of negative 30 is actually negative 0.5. So again, we get that v naught 0 for the second one is equal to negative 6 meters per second. So we can see these have the same speed. So they have the same absolute value of the velocity, but they have different directions, which is given by this plus sign or minus sign. We don't need the velocity in the x direction to do this problem, but if we did need it for a different problem, we could find that by using the cosine of 30 degrees, and you'd in fact find that it was the same. Cosine of 30 degrees is the same of cosine of minus 30 degrees. So, and that makes sense because both of these vectors are pointed in the same direction, which is this way for Vx. Okay. I'm sorry I flipped this around. So if I flip it around, x is positive in that direction and y is positive up still. But for what we're doing, we're only concerned with y in this one. Okay, so let's continue to organize our approach here. So now we know that v0 y for 1 is 6 meters per second. v0 y for 2 is negative 6 meters per second. And what we need to do now is figure out which kinematic equation we should use. So if we look back at our different kinematic equations, of those 4 that I gave you, there's one that uses the fact that we have an acceleration, which is this minus 9.8 meters per second squared. There's one that, and it also has a height, so we have this delta y is equal to negative 120 meters. So how do we know it's a negative 120 meters? It's because we have y naught is equal to 120. We have y final is equal to 0. And delta y is defined as y final minus y initial, which is negative 120 meters. And so there's only one equation that combines time, which is the other thing we want, with velocity, displacement, and acceleration, and that's the big equation, which says delta y is equal to v naught, in this case y, times time, plus 1/2 gt squared. And so this is the equation that we'll use. And now we've completely organized our approach, and we can now solve for the time for each of them, where both of these equations are going to use the same equation here, but the only difference is they're going to use these different velocities. Okay, so now let's go to analyzing our problem. I'll rewrite I'm going to actually draw a line down the middle so I can talk about stone 1 and stone 2 separately. And both of these are going to, let me erase down here at the bottom here, because both of these are going to use the same equations and a lot of the same numbers. It's just, what did I do that for? You guys, not a highlighter, eraser. Okay, so these are going to use a lot of the same equations. So for instance, the equation will be the same. Delta y is equal to v naught yt plus 1/2 gt squared. So why doesn't it like to draw that? Okay. And then the difference is v naught y is equal to plus 6 meters per second, and v naught y is equal to minus 6 meters per second. And the other things are the same. G is equal to minus 9.8 meters per second squared. Delta y is equal to minus 120 meters. And we're looking for t for both of them. Okay, so in both cases, the first thing we're going to do is rearrange this equation, because all of the terms here are going to stay, which means we have to use the quadratic equation. So I'm going to rearrange it so that it looks normal. 1/2 g t squared plus v naught y t minus delta y equals 0. Okay, so now we have, if this is a quadratic equation, this is a t squared plus b plus, I'm going to call that plus minus delta y plus c equals 0. b times t plus c equals 0. So now we can use the quadratic formula. Okay. at squared plus bt plus c equals 0. Then we use that t is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. All right, so plugging this in for in this case, a is equal to 1/2 g, b is equal to v naught y, and c is equal to minus delta y. And so we can plug this in, and t is equal to minus v naught y plus or minus the square root of v naught y quantity squared minus 4a, which is g over 2, times negative delta y. All that's under the square root, and then we can divide by 2 times g over 2. So this is the same equation that you use for both stones. The only difference is stone 1 will use positive 6, and you have to keep track of your minus signs in here. It's very important. Again, you're not going to be able to do a square root of something negative. So if you're getting a negative sign in here, make sure that you're keeping track that g is negative 9.8 meters per second squared. Also, you have to keep track that delta y is negative 120. On the top, you'll get a negative number. Again, g is a negative number on the bottom, and that will give you a positive time. If you plug in all of your numbers, you will get that time for stone 1 is equal to, and I did this out somewhere, I've got to plug it into my calculator. Okay, when I plug it in, all that stuff into my calculator, I get 5.6 seconds. I get, for stone 2, I get that it's equal to 4.4 seconds. And the question was, this is stone 2, t1 minus t2, and that's going to give us 1.2 seconds. That's the answer. Okay. And the last thing is to learn from our work. And so important things to take home from this one are that the direction of the initial velocity is important. Okay, and we can break v naught into x and y components. What else is important? The other thing was using that quadratic equation when you need to solve a problem with both t term and a t squared term. Okay, so I think that's everything, and that it was example 2.